Cone. A cone is a surface generated by a straight line passing through a fixed point and moving on a closed curve. The fixed point is called the vertex. Height of the cone. The perpendicular distance from the vertex of the plane of the base is the height of the cone. The length of the segment OA is the height of the cone and is usually denoted by H. Axis of the cone. The line connecting the center of the base to the vertex is called the axis of the cone.
Slant height of the cone. The distance between the vertex and any point on the circumference of the base circle is called its slant height. The length of the segment OB is called the slant height of the cone and is generally denoted by L. Radius of the cone. The radius AB of the base circle is called the radius of the cone and is usually denoted by R. In a right-angled triangle OAB, OB square is equal to OA square plus AB square. L square is equal to H square plus R square. Implies that L is equal to under root H square plus R square. Right circular cone. If a right-angled triangle is revolved about one of its sides containing the right angle, then the solid thus generated is called a right circular cone. Volume of a right circular cone. Volume of a cone is equal to 1 upon 3 pi r square h. Surface area of a right circular cone. The curved surface area of the cone is equal to pi rl. Curved surface area of the cone is equal to area of the sector OAB equal to 1 upon 2 into length of the arc of the sector into radius of the sector is equal to 1 upon 2 into 2 pi r into L is equal to pi rl. Total surface area of a right circular cone. Total surface area of the cone. Curved surface area equal to lateral surface area plus area of the base of the cone is equal to pi rl plus pi r square is equal to pi r into L plus R. Right circular cone. Example. Find the curved surface of a right circular cone whose slant height is 25 cm and the radius of the base is 7 cm. Solution. Slant height of the right circular cone L is equal to 25 cm. Radius of the base of the cone R is equal to 7 cm. Curved surface of a right circular cone is equal to pi r L is equal to 22 upon 7 into 7 into 25 centimeter square is equal to 550 centimeter square. Example. Determine the volume of a conical tin having radius of the base as 30 centimeter and its slant height as 50 centimeter. Find its total surface area also. Use pi equal to 3.14. Solution. Radius of the base of the cone R is equal to 30 centimeter. Slant height of the cone L is equal to 50 centimeter. Therefore, height h is equal to under root L square minus R square. Implies that h is equal to whole under root 50 square minus 30 square is equal to whole under root 50 minus 30, 50 plus 30 implies that h is equal to under root 1600 is equal to 40 centimeter. Volume of the conical tin is equal to 1 upon 3 pi r square h is equal to 1 upon 3 into 3.14 into 30 square into 40 centimeter cube is equal to 37,680 centimeter cube. Total surface area of the conical tin is equal to pi rl plus pi r square is equal to pi r into l plus r is equal to 3.14 into 30 into 50 plus 30 is equal to 3.14 into 30 into 80 is equal to 7,536 centimeter square. Frustum of a cone. Frustum of a cone is the solid obtained after removing the upper portion of the cone by a plane parallel to its base. Height. The perpendicular distance between the plane and the base is called the height of the frustum. Volume of a frustum. Let R1 and R2 be the radii of the bottom and top of the frustum, respectively, and h be the height of frustum. Volume of frustum is equal to volume of bigger cone minus volume of smaller cone is equal to 1 upon 3 pi r1 square h1 minus 1 upon 3 pi r2 square h2 is equal to 1 upon 3 pi within brackets r1 square h1 minus r2 square h2 is equal to pi upon 3 within brackets r1 square r1k minus r2 square r2k within brackets h1 upon r1 is equal to h2 upon r2 is equal to k. h1 is equal to kr1, h2 is equal to kr2 is equal to pi upon 3 k within brackets r1 cube minus r2 cube is equal to pi upon 3 k within brackets r1 minus r2 within brackets r1 square plus r1 r2 plus r2 square. Volume of frustum is equal to 1 upon 3 within brackets kr1 minus kr2 within brackets pi r1 square plus pi r1 r2 plus pi r2 square is equal to 1 upon 3 within brackets h1 minus h2 within brackets pi r1 square plus under root pi r1 square pi r2 square plus pi r2 square is equal to h upon 3 within brackets a1 plus under root a1 a2 plus a2 where a1 and a2 are the areas of the bottom and top respectively and h is equal to h1 minus h2. Volume of frustum of the cone is equal to h upon 3 within brackets a1 plus under root a1 a2 plus a2 is equal to h upon 3 within brackets pi r1 square plus under root pi r1 square pi r2 square plus pi r2 square is equal to pi h upon 3 r1 square plus r1 r2 plus r2 square. surface area of the frustum of a cone. Let R1, R2 be the radii of the bottom and top of the frustum respectively, and L be the slant height of the frustum. Surface area of frustum is equal to surface area of bigger cone minus surface area of smaller cone is equal to pi R1 L1 minus pi R2 L2 is equal to pi within brackets R1 L1 minus R2 L2 within brackets L1 upon R1 is equal to L2 upon R2 is equal to K. L1 is equal to KR1 and L2 is equal to KR2 is equal to pi within brackets R1 KR1 minus R2 KR2 is equal to pi K within brackets R1 square minus pi 2 square is equal to pi K within brackets R1 minus R2 within brackets R1 plus R2 is equal to pi within brackets KR1 minus KR2 within brackets R1 plus R2 is equal to pi L1 minus L2 within brackets R1 plus R2 is equal to pi L within brackets R1 plus R2 is equal to semi-perimeter of top and bottom into slant height. Total surface area is equal to lateral surface area plus area of top plus area of bottom. Pi within brackets R1 plus R2 L plus pi R1 square plus pi R2 square. Relation between L, H, R1 and R2 in right-angled triangle ABC. AB square is equal to AC square plus BC square implies that L square is equal to H square plus within brackets R1 minus R2 whole square. Example related with frustum. If the radii of the circular ends of a conical bucket, which is 45 cm high, are 28 cm and 7 cm, find the capacity of the bucket. Solution given H is equal to 45 cm, R is equal to 28 cm and R is equal to 7 cm. Capacity of the bucket is equal to 1 upon 3 pi H into R square plus R square plus RR is equal to 1 upon 3 into 22 upon 7 into 45 into within brackets 28 square plus 7 square plus 28 into 7 is equal to 22 upon 7 into 15 into within brackets 784 plus 49 plus 196 is equal to 22 upon 7 into 15 into 1029 is equal to 48,510 centimeter cube. A friction clutch is in the form of the frustum of a cone, the diameters of the ends being 8 cm and 10 cm and length 8 cm. Find its bearing surface. Solution. Radius R1 is equal to 10 upon 2 is equal to 5 cm. Radius R2 is equal to 8 upon 2 is equal to 4 cm. Slant height L is equal to 8 cm. Area of the bearing surface of the cone is equal to pi into R1 plus R2 into L is equal to 3.14 within brackets 4 plus 5 into 8 is equal to 3.14 into 9 into 8 is equal to 226.08 square centimeter.